Hello all of you all, welcome to the paper discussion of JEE Mains January 21st Shift 1. Myself Dr. Sheikh Sarfraz from Infinity Learn by Sri Chaitanya. So dear students, we will discuss this paper today and have a detailed solution and review of the paper. Okay. So let us start the paper, dear students. So the first question which appeared in the examination is MnO4 minus 2, that is manganate ion. MnO4 minus 2 manganate ion is treated in acidic medium. So we know that in acidic medium it forms MnO4 minus 1 plus. In acidic medium it always forms MnO2. So now if you see from year to year it got, so this is plus 6, this is plus 7 and this is plus 4, right. So hence now you can see this is oxidized and this is reduced. Can you see all of you all? So hence the answer is option 4. Got it, dear students? Next, in Carius method, 0.75 grams of organic compound gave 1.2 grams of barium sulfate. So all of you all, what to do? Step 1, you have to take the reference. So whatever barium sulfate is formed, so barium sulfate has sulfur. So you can see 233 grams of barium sulfate will have 32 grams, right. Then how much is 1.2 grams of barium sulfate? 1.2 grams of barium sulfate will have X. Then the step 2 will be percentage of sulfur. If you want to find out, it is X divided by weight of organic compound is 0.75 into 100. Okay, dear students. So on solving you will get approximately 22, you are going to get the answer. Okay. Next, given below the number of species. Okay. So he gave some species, SF4 ammonium ion complexes he gave and non-complexes he gave, and that he is asking tetrahedral geometry compounds are 3. So let us see. So everybody can see SF4 and SCF4, they belong to same group. So SF4 and SCF4 both are seesaw, right, and ammonium is tetrahedral, correct. Ammonium and even NiCl4 complex is tetrahedral, correct, and NiCN taken 4 times minus 2 complex is what? Square planar. And platinum complex is also square planar. So overall all of you can see tetrahedral complexes are only 2, not 3. Hence this statement will go wrong, right. This statement will go wrong. Next, in set of NO2, you know this has odd electron, incomplete octet, all are incomplete octet compound, yes, because beryllium compounds, boron compounds, aluminum compounds, all these are having incomplete octet. 6 electrons around the central atom, 6, 4, okay, and odd electron, unpaired electron. Hence answer is option 3. Identify the correct statement. So this question, dear students, is based upon memory based of essential and non-essential amino acids, but however you can do it. Let us start. So correct statements. Arginine and tryptophan are essential amino acids, correct. Histidine does not contain heterocyclic ring, wrong. Everybody should know histidine contains imidazole ring. So this statement is actually wrong. Proline is 6-membered ring cyclic amino acid, wrong. Proline is only 5-membered. So this is also wrong. Glycine does not have chiral carbon, correct. Glycine does not have chiral carbon, NH2, CH2, COOH. Cysteine has characteristic feature of side chain, yeah, no, it has sulfide link, sulfides, okay, SH it has, cysteine and cysteine, SH and disulfide bonds it has. Hence, answer is A and D only. Next, students, for a reaction, okay, here the question from chemical equilibrium, for a reaction, okay, standard free energy change for the reaction is, no, this is actually driving force. So, here you can see this part is the driving force, right. So, hence here you can see in this graph you can see you are starting from A, E and it is going up to B, okay. Equilibrium is attained at the central position and this is the fraction of N2O2 dissociated in terms of one scale, right. So, now everyone delta G in the graph is positive, N2 will not dissociate, no, this is wrong statements. What is asking? Correct statements, okay, sorry, he is asking correct statements. So, this becomes wrong, this is wrong. Next, reverse reaction will go to completion, no, because this is equilibrium, so it will not go to completion. Next, when 1 mole of N2O4 changes into equilibrium mixture, the value of delta Ng here, yeah, here you can see this is the driving force, okay. So, this will become the driving force. Got it, dear students? Next, when 2 moles of N2O4 changes into equilibrium, the mixture is minus. So, here everybody can see in this particular example, delta G naught is written as minus 0.84 minus 5.4. So, it will become minus 6.2. So, this statement is also correct. This we will solve in next page, okay. A hydrocarbon P C4H8. C4H8 means it can be cyclobutane or it can be butene or 1-butene or 2-butene on reaction, but he is saying that it is giving only one compound optically active. So, hence the compound we can take is this one. If you treat with HCl, Markovnikov addition, right, and this is Cl, right. Compound Q, which on reaction with 1 mole of ammonia gives compound R. With ammonia, it gives compound R. R on diazotization followed by diazotization means on treatment with HNO2, it forms N2 plus, and on hydrolysis forms, gives S, right. Hydrocarbon P, reaction with HCl optically active Q, R, S, right. So, hence here dear students, answer which is matching with us is option 3, right. An organic compound P on treatment with aqueous ammonia under hot conditions form Q. On heating with, here you can see very cleanly bromine in KOH. Bromine in KOH is either haloform reaction or Hoffman degradation reaction, correct. Having molecular formula C6H7N. So, if nitrogen is there, it is clearly indication it is amide. Hence, the compound must be benzoic acid, okay. When you heat with ammonia in hot concentrated condition, it should form amide, and this amide on Hoffman degradation will give you amine with 1 carbon loss. So, what is the question? The question is PQRR. So, obviously, it should be answer 1, straightforward from the equations. We now from the following least stable structure. So, everybody can see answer is 3, because here you can see same charges are very near and this will create high repulsions. This will create high repulsions and obviously it will increase high energy, whereas this you will not find in other examples. An organic compound P with molecular formula gives positive hydroform test. So, if the compound is giving positive haloform, that means P have C double bond to CH3, confirm. If it is giving haloform, then P should have methylated alcohol or ketone and not giving toluene. So, if you do with toluene, it is giving negative. When P is treated with dilute acid, it produces Q. Q gives toluene. Okay. P when you treat with dilute HCl, okay, or acid, it gives what? Q. And Q is giving toluene. That means in Q, you are having aldehyde group as well as methylated ketone part. And that aldehyde is absent here. Here aldehyde should be absent. Correct? So, hence, satisfying these conditions, you can see initially methylated ketone is not there in 3, it is there in 1, 2 and 3. On hydrolysis, this will give you ketone, so this cannot be answered. On hydrolysis, this will give you 1,2-diols, it cannot be the answer. On hydrolysis, here you can see OH will form on the same carbon, it lose water and form aldehydes, hence answer will be option 1. Given below are two statements, okay, given I can see the number of pairs among the following, right. So, two different statements are given. So, let us see what is asking. Among tetramine copper complex, nickel complex, Mn has maximum number of unpaired electrons. This is true. Why? Because everybody can see, the reason is very simple. You can see Mn is in +2, that means it is D5 configuration and no one can have this many number of d electrons. So, obviously, it will have highest number of 4s will be 0. Correct. Next, the number of pairs among this that contain only diamagnetic species. See, I will write P for para, D for diamagnetic. Okay. So, here you can see this is paramagnetic, this is dia, this is paramagnetic, this is diamagnetic, this is diamagnetic, this is diamagnetic. So, that contain only diamagnetic species, you should know only one set has diamagnetic species, hence this statement will become wrong. Next, which of the following represents the correct trend for the mentioned properties? Okay. So, fluorine first ionization energy, we know that from left hand side to right hand side ionization energy increases because non-metallic character is increasing, correct, hence this is correct. Chlorine, fluorine, sulfur, electron affinity, it is 100% correct. Chlorine has highest than fluorine, fluorine is second highest, okay, and remaining follows, correct. Next, metallic character, potassium, no, after potassium then comes magnesium will come, so this is a wrong statement. Next, basic character, K2O, Na2O, MgO, Al2, yes, correct, because on hydrolysis this will give potassium hydroxide, sodium hydroxide, magnesium hydroxide, aluminum hydroxide, amphoteric, from basic it is becoming amphoteric, correct. So, answer is option ABD. Next, 80 ml of hydrocarbon on mixing with 264 ml of oxygen 1 minute. So, hydrocarbon is what? CXHY is reacting with oxygen. Obviously, on combustion it will give you carbon dioxide and it will give you water, correct. So, this is X here and this will be Y by 2. 2 cancel, you will get Y moles of hydrogen. So, 80 ml, so you are taking 80 ml of this. On mixing with 264 ml of oxygen, so 264 ml of oxygen is taken, burnt, okay, undergoes. The residual gas after cooling occupies 224 ml when system is treated with potassium hydroxide. So, what potassium hydroxide will do? It absorbs carbon dioxide. The volume decreases to 64 ml, that means 64 ml should be who? 64 ml should be who? Water. So, if 64 ml is water, then 224 ml minus 60, so 160 ml will be carbon dioxide. Now, if you find the ratio very easily, you will get answer C2H2, right. Next, the number of pairs among the given are, the number of pairs among the given which contain oxides are both amphoteric. So, see, I will use A for acidic, Am for amphoteric, right. So, everybody should see this is acidic, this is acidic. Here one oxygen is extra, typing mistake, it's okay. So, here both are amphoteric, here also both are amphoteric. These are basic in nature. So, hence what is he telling? Okay, true statement there, right. BF3 is an electron deficient molecule, acts as Lewis acid, forms adduct with NH3. Yes, obviously, we know that this is NH3, this has lone pair, this is BF3, it has vacant orbital, this lone pair shifts there, and here you will get NH3, you will get BF3. This is the adduct. Statement is correct. Next. Now, this is another question from colligative properties. He is saying elements P and Q form two non-volatile, non-ionizable. So, this word is given non-volatile, non-ionizable to say Van 't Hoff factor is 1. This word is giving hint that Van 't Hoff factor is 1. Compounds PQ and PQ2. When 1 gram of PQ2 is dissolved, okay, two comparisons he is doing here, you can see very clearly. So, first we will study about PQ. Okay, first I will study about PQ, right. So, if I use the formula, what is saying 1 gram. So, weight is 1 gram, very fine. Dissolved in 50 gram, that is solvent, weight of the solvent capital W 50 gram. Delta TB was, okay, delta TB was 1.176 Kelvin. While, okay, now he is comparing, I will write here PQ2. How much is the weight? 1 gram only, okay, 1 gram, weight of the solvent is 50 only, and delta TB is 0.689, okay, and for both Kb is 5 given. Then the molar mass of P and Q respectively are. How to solve this? Here you see. For this I will write delta TB, for this I am writing delta TB is equal to Kb into weight by gram molecular weight into 1000 by capital W in grams, correct. For this delta TB is 1.176, Kb 5, weight is 1, gram molecular weight I have to find out into 1000 by 50, correct. Now, for that one I will write, so gram molecular weight on solving, here you will get 85. Now, if you come to this side, same if you do for this one, or I will rub off PQ2. So, 0.689 is equal to 5 into 1 by gram molecular weight into 1000 by 50. So, on solving this gram molecular weight, you will get 145. So, here P plus Q is 85, P plus 2Q is 145. On solving, you will get P and Q values. Got it, dear students? Next, identify the correct statements for the following. Propanol and propanol are functional isomers. True. Ethoxyethane, and methoxypropane are metamers. Correct. But2-ene shows optical isomerism. Wrong. But1-ene and 2-ene are functional. They are positional isomers. Wrong. Pentane and 2,2-dimethyl. Pentane and 2,2-dimethyl propane are chain isomers. Correct. So, answer is A, B, E. Next. Very easy reaction, dear students, this is A, if you treat with hydrogen, you are getting this. With this A you cannot find, because double bond can be anywhere, but from here you can easily find. On treatment with KMnO4, you are getting the corresponding product. That means this carbon and this carbon should be connected in the reverse compound. So this ring is not disturbed because it has all single bonds. That means it should, if you go, the double bond should be here. So hence they are disconnected from here. Right? Oh, sorry. I did mistake there. They should be here, because, yeah, right, hence only the answer possible is option 3. Next, which of the following graphs P versus V maximum work is done? So everybody should know that maximum work done is nothing but area under curve, or it is also called PV work. And work done on system is positive. Correct? So based upon the simple calculations, you can see answer is option 1, because it has maximum area under the curve. Correct? Out of the all other graphs. When electric discharge is passed through gaseous hydrogen, the hydrogen molecule dissociates. Okay. Okay, fine. And energetically excited hydrogen atom produce electromagnetic radiations of discrete frequency. Correct, because they can further undergo ionization to produce H plus and electrons which can undergo excitation. Okay, same thing will happen in discharge tube, in the discovery of electron proton which we have done. The frequency of second Barmer line of helium is equal to that of first line of Lyman obtained from hydrogen. It is correct, because students, first line of hydrogen of Lyman will be equal to second line of helium plus 2 of Balmer. Similarly, third line of Li plus 3 of Patchen, and so on. Frequencies will be same. This is very easy question, dear students. Lead chloride and potassium dichromate becomes PbCrO4, which is very famous yellow precipitate we do in salt analysis. This compound A on sodium hydroxide, okay, it produces the corresponding compound. So hydroxide is done, so obviously it will form hydroxide is given, lead hydroxide will form. Now lead sulfate is given here. Okay, X means what? X will be lead acetate, Pb, CH3COO taken 4 times, right. Okay, so very simple and straightforward question. 14 grams, oh, very easy question. 14 grams of calcium metal, calcium plus HCl gives calcium chloride plus hydrogen. If you want to balance, here you can write 2. That means if you have chemical law of equivalence, number of moles of calcium upon 1 will be equal to number of moles of HCl upon 2, which will be equal to number of moles of calcium chloride upon 1, which will equal to number of moles of hydrogen upon 1. Next. Now dear students, this is very simple and important and useful expression. The pre-exponential factors of 2 different reactions of the same order. So here you can see, let the activation energy of first reaction exceeds the activation of second by 20 kilojoules. So here you can see, here it is given in joules and here kilojoules. So remember this 20 you have to multiply by 1000, so that first of all everything comes in same units. K1 and K2 are the rate constants of first and second respectively at 300 Kelvin. Then K2 upon K1, ln it should be. I think this is ln, not in. Okay, no problem. So we can write ln K2 upon K1 is equal to activation energy second minus activation energy 1 upon RT. So, ln K2 upon K1 will be equal to 20, the difference is already given, upon 8.3 into temperature, how much? How much is the temperature? 300. So, on solving this, you will get the answer, corresponding answer 8. Okay, corresponding answer 8 will come. Next, another easy question. So, this is nothing but everybody should know that this test is very famously called Chromyl chloride test, right, where orange color vapors are obtained. So, this is test for chloride actually. So, chloride ions when you treat with potassium dichromate in sulfuric acid gives chromyl chloride CrO2 Cl2, right. Then chromyl chloride CrO2 Cl2 is treated with B and B with sulfuric acid to give C. Everybody should know this problem repeatedly coming in JEE. So, everybody should know, we have studied this so many times. C is CrO5 chromium peroxide, which is a blue color compound. Okay, it has structure of butterfly if you remember. What is the question? In the product C, X is the number of peroxide ions. So, everybody can see X is 2, you have 2 peroxy linkages. Y is the total number of oxygen atom present in the compound. So, Y is 5, you can see 5 oxygens are there. And Z is the oxidation state of chromium, it is 6. So, if you add it, you will get answer 13, right. Next, easy question, this is very easy question actually, very easy. Concentrated sulfuric acid, you know, we will get nitrobenzene, correct. On tin reduction, you are going to get what? Aniline. Aniline on reaction with acetic anhydride will give N-acyl aniline. With concentrated acid, it will give you para-nitro product. Then on hydrolysis, the final product will be NH2, NO2. Okay, correct? Yeah. The percentage of nitrogen in the product formed is, so very easily you can find. So, C6H N O O2 N2 4 5 6, right. So, percentage of nitrogen is nothing but, how much is nitrogen here? 28 divided by the molecular weight of this, which you can find out, into 100, right dear students. pH and conductance of weak acid was found to be 5. So, all of you all we should know that pH is 5, that means concentration of H plus ions is 10 to the power of minus 5. And conductance C, C is equal to, how much he gave? 4 into 10 to the power of minus 5, this is nothing but 1 by R. The conductance was measured under standard condition using a cell where the electrode plates have a surface area L by A given, L by A is given and the distance is 15 centimeter apart. Limiting molar conductivity. So, very easy, limiting molar conductivity is equal to K into 1000 upon molarity, right, right. So, now how to find K? R is equal to rho L by A. So, once you get R is equal to rho from this data, if you get R is equal to rho L by A, inverse of rho you will get K and you will get the corresponding answer. Okay dear students. Next, now data is given here for enthalpy entropy for AB, A2, B2 in kilojoules per mole, and here you can see he is given for joules per Kelvin. 1 mole of each A2 and B2 are taken in 1 liter vessel, allowed to establish equilibrium at 500 Kelvin. Reaction is given, value of X he is asking, right. Now, dear students, how to do this? So, everybody should see the first important thing here is we should know that delta G is equal to delta G naught plus 2.303 nRT log base 10 Q. At equilibrium, delta G will become 0. So, delta G becomes 0, Q will become K. So, delta G naught is equal to minus 2.303 RT log base 10 K. So, from this data, how to find out delta G? We can find out by that equation. So, now you can see A2 plus B2 gives 2AB. Now, you can see if you take delta H naught, if you see B2 he is saying X, A2 he is saying 6, and AB is 2 times of 32, correct? Next, delta S naught entropy, this is 280, A2 is 146, and this is 2 into 222. So, from this you can easily find delta G. Once you get delta G naught, then delta G naught is equal to delta H naught minus T delta S naught. So, therefore, once you get delta G naught is equal to delta G naught plus T delta S naught. You will get the answer approximately 70. Okay, dear students. So, thank you all of you all. So, this was the paper discussion for our 21st Jan shift 1. In next class, we will see the further shift. Thank you all of you all.